Good morning and thank you for joining us today. We'll start the session in a minute or two. Good morning and thank you for your patience. Welcome to the session Unlocking Scalability and Flexibility with Amazon DocumentDB, a deep dive into MongoDB compatibility with AWS, hosted by Cloud.in. I am Suvarna Jadhav working with Cloud.in as a strategic partnership and alliance manager. For today's session, we have Ms. Rutuja as a speaker. Rutuja is working with Cloud.in as a cloud consultant. This webinar is your gateway to discovering the power of scalability and flexibility in a modern database management. By the end of this session, you will learn how Amazon DocumentDB provides compatibility with MongoDB, allowing you to seamlessly migrate your MongoDB applications to the AWS cloud. Before starting the session, I would like to mention a few points. All attendees are muted by default and cannot be unmuted during a session. If you have any questions, you can type in chat box. I request Rutuja to start the session. Over to you, Rutuja.
Thank you so much, Suvarna ma'am. Hi all, good morning. Let us begin the session. So, firstly, we'll be looking at the agenda for today's session. Just a minute. Suvarna ma'am, is my screen visible?
Yes, Rutuja, your screen is visible.
Can you see the agenda slide?
No. Can you please move your slide?
Yeah, I have. Just a minute. I guess there's some internet issue.
Yes, it's visible now.
Yeah, thank you. Sorry for the inconvenience. So looking at the agenda, firstly, we'll be looking about we'll have a brief introduction about what is MongoDB as a technology and what is its importance in a business. Next, we'll be looking at a service that's called DocumentDB, which is basically purposely built for MongoDB workloads. And we'll also look into the architecture and the best practices that should be followed for a service like DocumentDB. And also we'll be looking at an open source software as a service provided by AWS, that is MongoDB Atlas. How can you migrate that software as a service and use it on your AWS environment? And also following that, we have a case study to understand it in a real-time example. So moving on, let us look into what is MongoDB. So as we all know, MongoDB is a very popular open source and it is a document-oriented NoSQL database. So these are very flexible and semi-structured documents which are in a format of JSON, similar to the format of JSON. And these documents can contain like key value pairs, arrays, and nested structures. So they allow you to have need to have any schema, so you can easily work with such databases. Also, as I said, they are NoSQL databases, so they fall under the category of NoSQL databases, which are basically designed to handle the large volumes of unstructured or semi-structured data, and you can efficiently work with these databases rather than working with the other traditional relational databases. And it also offers you the horizontal scalability and high availability if you correctly migrate them into the appropriate cloud providers that you have. So the importance that we see in a business perspective while using MongoDB into your uh, application. So MongoDB basically offers businesses a very flexible and scalable high performance database solutions. So this can let you adapt. This actually adapts the evolving needs that we have right away. Like nowadays in market, there are a numerous amount of data, and you can actually adapt this solution to with for the enormous amount of data that you currently have for your application by easily scaling it and getting a very high performed database. Also, its importance lies in the enabling agile development, supporting the real-time analytics in picture, and also it empowers the businesses to make data-driven decisions in the fast-paced market that we have. So you can, as you all know, the world is growing very fast. So you will need solutions that come up with faster implementations. And with MongoDB in picture, you can actually achieve all this. Also, it has flexible data modeling, which adds into the businesses. So the schemaless design that MongoDB has in it, it allows the businesses to actually store and manage the diverse data types within the same database. So this makes it ideal for example, the applications with the evolving data models, and whether it's, for example, you can consider customer profiles or any product catalogs or any sensor data. MongoDB can easily adapt to the changing data requirements in your application without requiring you to have any extensive schema modifications to be done in your database. Next feature, as I said, the agile development one. So MongoDB enables the agile development practices in it. And this feature actually allows the developers in a business to basically iterate very quickly and the applications that they are developing. So this method is very flexible, and as you know, MongoDB is rich in querying. It has rich querying capabilities, and this also empowers the developers to actually make the changes to the data model or the application logic without actually disrupting the operations or even requiring any complex migrations to be done. So yeah, this was a very brief introduction about what MongoDB as a technology is. Moving on, let us dive into the purpose-built service by AWS, by what AWS provides us, that is DocumentDB. So as the name suggests, DocumentDB is a document database service that is purpose-built for the JSON data management. So if the JSON in a document format database comes into picture, MongoDB is the perfect one, and DocumentDB is basically built to be compatible with the MongoDB workloads that one has in its applications. So in DocumentDB, the data management is at scale, and it is completely managed and integrated with AWS. So the basic patching and maintenance of the service is not to be done by the developer or the business or whoever the workload is, whoever's the workload they have it in. The AWS does it at its end. It is done in the backend. You don't need to maintain the service and you can focus on your development. Also, it is enterprise ready and it is highly durable. This service is very scalable and it also offers the customers the durability needed when they are operating with, for example, very mission critical MongoDB workloads. So you can actually focus on your development and application building rather than maintaining this database. So looking at the key features of what DocumentDB gives us, firstly we have the elastic clusters, DocumentDB elastic clusters. So this actually enables the customers to handle millions of writes and reads per second. Also, it allows the customers to scale their document databases in minutes and with near to zero downtime. And also, it won't impact your performance of the application. So customers can also basically store around petabytes of data and only pay for the capacity that they consume. And there, as I said, there is no management since the services are managed service by AWS. And with Amazon DocumentDB, you can Elastic clusters, you can meet the scaling needs of any virtual application that you have running. The next key feature that we have is, as I said, MongoDB compatibility. So this compatibility is with the MongoDB versions that are 3.6, 4.0, and 5.0 drivers and tools. So it has a vast majority of the applications, drivers, and tools that customers already use in their open source MongoDB non-relational database and can be used on DocumentDB as well. So DocumentDB also emulates the responses that a client expects from a MongoDB server by implementing the Apache open source version of MongoDB. And yeah, so you can have a MongoDB compatible DocumentDB service. So you don't need to hustle around every time. Next key feature that we have in picture is very advantageable. That is low latency read replicas that you can have. So this actually increases the read throughput and supports high volume application requests. And it also lets you create around 15 database read replicas. So you can have at the max 15 read replicas, which is a very huge number. So your primary database will be doing the write and read operations, but the read replicas you can have replicas around just for any failover or any other disaster to be taken if. So this can save you from such disasters. So next in line, we have the architecture. So as you all can see in the architecture, we have a primary database over here, which is doing the read and write operations with the storage that is aligned to it. And you have two replicas in the picture, which have their own volumes attached as well. And they are also deployed in different availability zones. So this also gives you a very high availability for your application. So I'll just brief you about the architecture. So this architecture is of a cluster. So a cluster basically consists of one or more instances, as you all can see, and that provides the instances. Obviously, they provide you compute, and it also has cluster volume for the data of the instances to be stored. So a cluster can have up to 16 instances, one considering the first one considering to be the primary one and the other as replicas. So 16 wherein one will be the primary and the other 15 will be the replica. And the cluster instances actually need not be the same instance size. So you can also have it according to your workloads. You can have a lower instance type or a higher one. It completely is dependent on your workload and your traffic. And so yeah, the primary instance here, the work that it does is it supports the read and write workloads and performs all the data modifications that has to be done to its cluster volume. So each Amazon cluster has to have a primary instance, and aligned to it, you have the cluster volume. So the cluster volume provides you an SSD-backed distributed storage for your database. And the primary instance and any Amazon DocumentDB replicas share the same cluster volume. And the replicas that you can see, these are supported. These support the read operations for the instance, and each DB cluster can have up to 15 replicas. And also, in case the primary instance, as I said, if in case the primary instance fails, one of the Amazon DocumentDB replicas can be promoted as the primary one. So you can easily promote your running replica into the primary one, which will give you point in time recovery from the failover. Next, let us deeply understand regarding the architecture, how it helps us achieve all the different factors. So you can recover from the automatic failover without having any data loss in picture. So DocumentDB uses the automated checks to detect failure of the primary instance in a cluster. So if your primary instance fails by any chance, so the DocumentDB actually automatically fails over to any of the other 15 replicas that you have running with minimal downtime and availability impact on application. So this gives you high availability when you create a cluster using the DocumentDB, and you choose to create a replica in a different availability zone, and you can create 2 instances. So this creates the primary instance in one availability zone, as you can see, and the other replicas are in the other availability zones. So if there is any failover happening, there cannot be any data loss, since the volume is in one, like they are sharing the same volume type. So you cannot have any data loss also coming into picture. And because the replicas, as I said, are sharing the same volume type, you cannot have any data loss. Next feature that we can avail. Yeah, so these are actually the typical deployment configurations. So for 99% of availability target, you have one instance and one availability zone. So the recovery time over here is 8 to 10 minutes. So to achieve 99, so you can achieve actually 99.99% of availability if you have DocumentDB aligned, wherein you can have total instances, 4 total instances, 3 replicas, and 3 different availability zones. So this will give you near to less than 30 seconds of recovery time, which is very huge. Like you can recover instantly. Next in line, we have the scalability factor. So yeah, scalability is a huge thing, and it is very needed nowadays in market, because since the market is growing and you have a lot of data, so you can scale. There is a need of scaling every now and then, and DocumentDB is very efficient in this matter. So the DocumentDB is designed in a very highly scalable way. It can be scaled vertically as well as horizontally. You can scale vertically by actually increasing the size of your instances, and you can also scale horizontally, that is scale out, by increasing the number of read replicas, that is up to 50. So the primary instance here and the read replicas share the same storage, and the read replicas can be added in a few minutes with minimal impact on the database availability. So while your other read replicas are added, you are not affected with the performance of your primary instances. It will not it will not simultaneously affect your performance, which is running because of your primary instance. And also you can automatically scale your database up to your database storage up to 64 TB as your data grows, and you can only pay for the storage that is being currently used in your workload. So you don't pay for the complete 64 TB even if you're not utilizing it. You will only pay for the amount that you are actually utilizing in your work. So as you can see, they are also decoupled in nature, the compute and the storage part. And here, as you can see, you can scale up, which is vertical scaling by increasing the instance size, and scale out by increasing the number of read replicas. So scaling up, as I said, starting from you have instances starting from T3 medium with 2 vCPUs and 4 GB RAM to R5 24X large instance, which has up to 96 vCPUs with 768 GB of RAM. So you can actually have the lowest from 2 to 4 to the highest from 96 to 768 of config instance. And the complex list of DocumentDB instance types and regional availability can be found on the website also. You can just check out and avail any of the instances according to your workload. Coming to the horizontal scaling part, as I said, you can add read replicas according to your need, as much as you want, up to 15. And the read replicas can scale your read capacity to millions of requests per second. So the read replica lag is very low, usually less than 100 milliseconds. Obviously, if you have multiple read replicas running around, you will not face any lag in your read operations, because the read replicas and the primary instance share the same storage volume, and you can add read replicas in minutes. So as I said, the decoupled compute and storage part. So there are the compute and storage layers are actually decoupled in DocumentDB and can be scaled independently. So you are not affected either way. And the primary instance and the read replicas share the same cluster volume. Adding any read replica or replacing a failed instance does not require you copying of any data and can be performed in a few minutes regardless of the size of your data. So since they are sharing the same storage volume, you don't need to make any copies or, for example, as we usually do for the EC2 instance part, create the AMI and then do it. So you don't need to have all of that done. Since they share the same one, it can be easily aligned accordingly. Next in line, we have the best practices. Yes, so after you are very familiar with the architecture and all the features that you get availed with DocumentDB, there are some best practices provided by AWS that you should avail while using specific services in AWS environment. So for DocumentDB, by following these basic operational guidelines, you can work seamlessly with your DocumentDB service. So firstly, you should be deploying a cluster consisting of 2 or more DocumentDB instances into availability zone. For the production workloads, you can deploy a cluster consisting of 3 or more DocumentDB instances in 3 availabilities. So easily, this is for your benefit. You can have high availability, obviously, with such approach, and it is also considered as a best practice, since in case of any failure, you can easily recover. Also, you should be monitoring your memory, CPU connections, and storage usage. So to help you maintain system performance and availability, you can set up CloudWatch, which is a monitoring service in AWS, to notify you when the usage patterns change, and you can approach the capacity also of your deployment. So like you can keep a watch by monitoring your usage, and you can also, this also helps you scale up and down whenever your usage is low or high. Also, set a backup retention period to align with your recovery point objective. So if you have a recovery point objective, you have a certain timeline to you have certain RPO, you should align the backup accordingly, satisfying the RPO that you have for your application. Also, choose a driver read preference setting that maximizes the read scaling while meeting your application's read consistency requirements. So this, the secondary preferred read that you have can enable the replica reads and frees up the primary instance to do more work. So in this case, you can actually route the read operations to the replicas itself, and you can have the primary doing read and write, which are so like the concurrent read operations can be routed to the other read replicas that you have in your architecture. So that can be handled by the replicas, and your primary instance can focus on the new read and as well as the write operations that are running. You should design your application to be resilient in the event of network and database errors. So you can use your driver's error mechanism to distinguish between the transient errors and the persistent errors. So retry transient errors using an exponential backup mechanism when appropriate, and ensure that your application considers data consistency when implementing retry logic. Also, when creating an DocumentDB cluster, the engine version that is being used is an optional parameter that defaults to the latest major engine version. So when you're creating a DocumentDB cluster, by default, the latest one is taken in consideration, and the current major engine is 4.00. So when new major engine versions are released, the default engine version for the engine version will be updated to reflect the latest one. So as a result, for production workloads, and especially those that are dependent on scripting automation or cloud formation templates, for example, we can recommend that you explicitly specify the engine version that is being intended to use for the application to be run. So these are some best practices that you should keep in mind while working with DocumentDB in your AWS environment. So moving on, there's another software as a service, you can say, that is in the AWS environment that you can avail for your MongoDB workloads, which is MongoDB Atlas on AWS. So you can prevail this on AWS Marketplace, and you can run it traditionally on an EC2 instance, for example. It is a software as a service. So MongoDB Atlas systems are basically a single tenant dedicated single tenant software, and this can be dedicatedly used on an EC2 virtual servers that are created. The EC2 instance can also be created specifically to be run, that should be running only the Atlas workload, the MongoDB Atlas workload. And the virtual servers are actually isolated within their own VPCs, and they do not share any logical data storage or processing with the other users. So the AWS data centers are compliant with number of security standards for using such workloads. So the highlights that MongoDB Atlas gives us, so it is secure by default since it is provided by AWS, and it leverages built-in security features across your entire deployment. Also, it has a native vector search capabilities embedded in an operational database, and you can revolutionize your mobile app development processes with the Atlas device sync that is in picture when you purchase it from the AWS Marketplace, which is a software as a service provider. So yeah, it is fully managed database as a service and is available on all the major cloud providers, as I said, for example, AWS Marketplace. And it is a single view with that aggregates data from multiple sources. It supports real-time data analysis, IoT applications, scalable mobile applications, and database personalizations at scale. Moving on, we have an example wherein you can use or you can deploy MongoDB Atlas on AWS in a serverless way. So the following diagram that you can see is a serverless reference architecture that uses Lambda functions. So it shows you the real-time extract, transform, load, the ETL that we say operations with the S3 in picture to the MongoDB Atlas that is on your AWS. So the key advantages, if you avail this architecture, you can get advantage of the infrastructure requirements with minimal management. Since all of these services are managed services, you will have a very minimal part of management to be done at your end. It is stateless design and it provides you radical scaling in response to your workloads. Also, it is an event-driven design which helps with the complex computations in picture. And the solution is very cost effective because you pay only for what you use. And also, the architecture supports the agility and availability because you can go global in minutes. So all of these services can be scaled as per your need, and it is very convenient to very convenient, agile, and available architecture, highly available architecture. So there are some steps, high-level migration steps that I would like to let you know about if you are migrating the MongoDB Atlas software as a service on your AWS environment. So once you deploy the MongoDB Atlas, you can use the Atlas Live migration service to migrate the data from your existing MongoDB environment. So if you have, since it is an open source, you have it running on your environment. So you can have it migrated using the live migration service, whether it's on the public cloud or it's in some of your data centers. Or even if you're using a third-party database, you can have this done with minimal impact to your applications. Also, the Atlas Live Migration Service makes an initial copy of the data from your source database that is actually running, and it watches for any changes so that it can sync. So that's the reason why it's named Live Migration Service. It lively migrates your data, and if there is any changes, it will keep an watch on it and have it synced immediately. So during this process, actually, your application can continue to the read and write from your source database. So as I said, the source database will be running, and you can have your read and write operations substantially be running on the source database itself. So when you are ready to cut over, when you are done with the migration, your data is completely migrated, you change the connection string to your application from the source database that was running to the Atlas cluster that has been migrated to your AWS cloud. So yeah, this was a very brief introduction and a very brief understanding about how you can have your MongoDB workloads run in an AWS environment with the DocumentDB and MongoDB Atlas software as a service in picture. So let us look at a very simple case study around this workload. So there's a customer named Rappi. So they are they are a multi-vertical technological platform that connects commerce, consumers, and couriers, allowing the delivery of almost everything. So it is just a delivery. It is like, for example, Zomato that we have right now. So it's a delivery app, and the business problems that they were facing. So they needed a data solution that needs to support multiple business applications across multiple countries. Since they were deployed around multiple countries, they needed a solution which will support them in multiple countries without having without having any single point of failures. So they needed flexibility in short, and also a solution that needs to be scaled independently. Different business units can peak at different times. So they needed scalability and performance also, and also with a small team in picture to be able to manage hundreds of databases. So they needed a solution which will be fully managed. So if you all can recall, we just saw a service that is fully managed and can scale and give you high performance, and also is very flexible. So just DocumentDB. Moving on. So yeah, before they were deployed on AWS, they had an architecture which had an arbitrary database also running, including the primary, secondary. There was another arbitrary database that was running. So we'll just look into in detail about what their use case and what their problems were. So since the they actually were already familiar with AWS environment, and previously they had a monolithic application with the traditional architecture design patterns. Later, they moved on with Elasticsearch, and the infrastructure served the company well as initially. It wasn't long before since they identified that it needed a database platform that could actually support more flexible microservices driven approach the facility and pace of innovation required to compete in the on-demand delivery business that they had. So the company turned, as I said, to Elasticsearch for catalog and search and set up a series of microservices organized by business unit and by country, with each country supported by one Elasticsearch cluster. But because every microservice within a country was using the same cluster, if something went wrong with any single microservice, it was established to many connections to the database or wrong index usage. So since there was only one Elasticsearch cluster being used across multiple countries, if any of the countries facing any issue by any connection issue or be it any other issue, all of the other countries were also affected because there was only one cluster in picture for example 10 countries. So if one country is getting affected, all the other 9 are also getting affected. So further, because RAPI was deploying one Elasticsearch cluster per country to cover all 9 lines of business in that country, the model used up to 100 nodes per cluster, which drove up to the price tag. Obviously, this will raise their cost to a very high limit, and it also slowed down the performance and also required a constant maintenance. So this actually this was a solution, but it also had many consequences aligned to it. So a solution that they drastically moved to was DocumentDB. They thought that they started to move on Elasticsearch to MongoDB, but maintaining infrastructure for so many MongoDB clusters was a challenge. And they found out about DocumentDB, which is a fully managed document database compatible with MongoDB and also allowed migration with few code changes. So now with the migration to DocumentDB was complete, the new model allotted one DocumentDB cluster per each of its 9 lines of the business per country, and it can change the exponential increase in clusters with just with a very minimal manpower effort. And in current situation, RAPI has the largest DocumentDB cluster of 5 instances, which took 2 weeks to migrate, and it resulted in a significant improvement in their performance and efficiency. Also, it has not experienced any DocumentDB related outages, and ranking query latency has dropped to 80 milliseconds in the 99th percentile. So they have seen a drastic change by moving to DocumentDB. Along with providing better performance, the managed DocumentDB service requires substantial less maintenance and firefighting, which frees up the data platform team to focus on value-adding activities that help move the app forward. So the outcome that they achieved by availing the DocumentDB services, that they dropped the number of outages from frequent to 0. They migrated over 100 live MongoDB databases to DocumentDB in 3 months, and they decreased the latency from up to 500 milliseconds to 80 milliseconds on average for the restaurants, and the ranking query also increased, and also they decreased the management and operational overhead by more than 50% since the service is already managed by AWS. So yeah, this was it about the RAPI use case. So yeah, this was about the whole session. We have understood how we can use MongoDB as a technology, which is a very in fashion and nowadays very highly used, which gives you flexible, scalable. You can have flexibility, scalability, and very well performance if you integrate it with the DocumentDB service that is provided to you by AWS. So yeah, thank you so much for being such a patient audience. Over to you, Suvarna ma'am.
Thank
Hello.
you, Kutuja. Thank you, Kutuja. Am I audible?
Yes, ma'am.
Okay, thanks for such an insightful presentation, and thank you all for attending the session. We appreciate your being with us today. We would like to get your feedback on the session, so I am pasting one link here in the chat box. We'll appreciate your feedback on the session to improve ourselves. Have a great day ahead. Thank you.
Thank you.